force is 0. Which is another way of saying the normal force never accelerates anybody. All it does is support you. And if it doesn't support you, you fall off, like in the revolution type ride, you know. If there isn't enough normal force, you fall. Okay? So the normal force doesn't push you forward, doesn't stop you, it just supports you. The friction force always does negative work because it's opposing your motion. Okay, so the work by normal force is 0, we said that. How about work by mg? Remember the other day we saw that the gravity only cares about the vertical distance that you rise, never the horizontal. So, and since you're rising, gravity is doing negative work, right? So what's the work done by gravity? Negative mgh. We can call this h here. Negative mgh. That's the work done by gravity. It only cares about the vertical displacement. And then that's equal to half m v final squared minus half m v initial squared. Okay, so now we put in all the numbers, and when we do that, we should get the same answer for the F that we did before. The same 1984. Okay, so let's put it in here. So bring this over here, and we have F times D is 1,000 minus mu k, which is 0.3, times the normal force, which is mg cos theta. So you still have to remember some of the things from Newton's laws. You have to remember that the normal force is for an inclined plane is mg cos theta. So it's 3,000 times cosine of 20 times the displacement d, which is 1,000, minus mgh, which is again a 3,000. 3,000 is the mg. The h is the vertical height. Now, in this problem, the height along the incline was given as 1,000. So the vertical height, h, is 1,000 sine of 20, right? So the gravity only cares about the vertical displacement. So negative 3,000 times sine of 20. And that's about it. So now that's equal to half times 3,000 divided by 32, because I'm changing to slugs. V final is 50 minus half times 3,000 divided by 32 times 10 squared. So with using work energy method, one whole equation, one step, solves the answer for you. You don't need to refer to kinematics. F is equal to, and you should get the same answer. Solve this, bring this over to this side, bring this over to this side. Oh, I forgot something here. Over here should be 3,000 is the mg. The h is 1,000 times sine of 20. So I forgot the 1,000. Actually, you can actually cancel the 1,000 here because we're solving for f. So cancel 1,000, cancel this 1,000, cancel this 1,000. Can't make this 3, make this 3. So it makes the numbers smaller. So now just solve the rest here. And you should get 1,984. Okay? You can double check that here while I erase this. It comes out. Yeah? Same, huh? Good. So, you see, it's more like a holistic one-step approach. Okay, what is the work of the engine? Part B. Then you just multiply the 1,000, the F times D. Times 1,000. You multiply the force by the displacement, and that's going to be 1.984 times 10 to the 6th foot-pounds. It's going to be a huge number. 1.984 times 10 to the 6th foot-pounds is the work done by the engine. And then C, the power of the engine, is work over time. Okay? And then you divide the work here by the time. Oh, and then remember the time we got 33.3 seconds. Okay. And now we can convert that to horsepower. So remember, 550 foot-pound per second is 1 horsepower. And we can see how much power output the car had during that trip. You got it?
108.
108? Point. So it wasn't really being used to the full potential of the power. I mean, you could still, the car was driving, I mean, they didn't floor it basically, you know. They were accelerated at a gentle rate, and their horsepower output was 108 horsepower. Okay, so you kind of can see a good example of power here, as well as how to find work. Okay, let's do something like this now.